What if you could turn your everyday microwave into a high-powered ceramic kiln? Sounds kind of like science fiction, right? Well, a really fascinating 2025 study actually made it happen. We're going to dive into how they managed to fire professional-grade ceramics in a modified microwave, and honestly, what it could mean for artists everywhere. Okay, let's just get right to the point. The reason this whole experiment is so exciting really boils down to this one simple fact. A normal ceramic firing takes what, pretty much a whole day, 8 to 10 hours, easy. The microwave kiln they built for the study, it gets the exact same job done in about an hour. I mean, come on, that is a total game changer for any artist or hobbyist out there. So here's our roadmap. We'll kick things off with a big idea itself, then we'll walk through how they actually built this thing. After that, we'll uncover the secret sauce that makes it all work, these things called homemade susceptors. Then we'll look at the firing process, the frankly amazing results, and wrap it all up with a really important look at safety and what this all could mean for the future. Right, so the goal here was pretty ambitious. Could they take a common, cheap microwave and transform it into a legit kiln for artists? The whole idea is to bring this really time-consuming industrial process right into a small workshop, making it way faster and more accessible for everyone. Now, I have to put a big flashing warning sign up here. We are breaking down a scientific paper. This is a proof of concept, and it is not a DIY guide. Seriously, you're dealing with incredibly high temperatures and high voltage. This is something that should absolutely not be attempted without expert knowledge and proper supervision. All right, with that very important warning out of the way, let's get into the build. So, how do you turn a microwave into a kiln that can hit over 1200 degrees Celsius? That's hot enough for porcelain, by the way. Well, it is all about the insulation. The researchers actually modified two different standard ovens, a smaller 18-liter one and a bigger 50-liter model. The basic mods were actually pretty straightforward. First, they yanked out the turntable to get as much space as possible. Then came the most critical part, lining the inside with some serious high-temperature insulation. They also had to upgrade the ventilation to make sure nothing overheated, and they installed special sensors to keep an eye on those crazy high temperatures inside. So, what they used for insulation is key. They layered it. On the outside, they used a biosoluble fiber. Then, for the inner walls, they used these things called JM23 refractory bricks. And for the floor, where it gets hottest, they used an even tougher JM26 brick. Now, what's cool about these materials is that they're not just great at holding in heat, they're also transparent to microwaves, which is absolutely essential for this to work. Here's the thing. A microwave can't just heat up cold clay. When clay is at room temperature, microwaves basically pass right through it. So you need something to get the heating process started. And this is where the real genius of this study comes in. These homemade things called susceptors. So yeah, I just threw this new term at you, this magic ingredient. But what on earth is a susceptor? Think of it like one of those special browning dishes you might have for your microwave, but on steroids. A susceptor is a material that gets incredibly hot, like instantly. It soaks up all that microwave energy, converts it into intense heat, and then radiates that heat onto the ceramic piece. That first blast gets the ceramic hot enough to start absorbing microwaves on its own. It's kind of like a two-step dance. The susceptor starts the party, and then the ceramic joins in. And what's really amazing is just how simple it was for them to make these things. They came up with a process that pretty much any craftsperson could do in their own shop. You just make some specific powders together, add water, pour it all into molds, and then get this, you use the microwave itself to fire them into solid, usable blocks. The recipe for these things uses really common, low-cost stuff. The main ingredient is silicon carbide. It's a standard abrasive powder. But the real activator is magnetite, which is a type of iron oxide. The study found it has to be a superfine sub-micrometer powder for it to work right. Then they just added some silica and alumina sand to give it some structure. Okay, so they basically came up with two main recipes. The one that was low on magnetite was super durable, really stable. But the one that was rich in magnetite, it had this really cool superpower. Now, it did wear out after about 10 or 15 firings, but because it had so much iron, it created a low oxygen atmosphere inside the kiln. Potters absolutely love this because it lets you create these really unique glaze effects you usually only get from a gas-fired kiln. Okay, so we've got our kiln, we've got our susceptors. Let's talk about the firing itself. See, firing clay isn't just about drying it. It's a whole series of permanent chemical changes that transform it from, well, mud into ceramic. As you ramp up the heat, the clay goes through these critical stages. At 100 degrees Celsius, the regular water boils off. Around 450, the water that's chemically bonded to the clay gets driven out, and that permanently changes its structure. Then, at 573 degrees, you get the quartz inversion, a sudden expansion in the silica crystals. If you heat up or cool down too fast through any of these stages, you can get cracks, which is why control is so important. So to manage all that, the researchers had a very careful plan. They ramped up the power slowly, especially for a raw, unfired piece, to avoid that thermal shock. In their big kiln that had 3 magnetrons, they'd turn them on one at a time to make sure the temperature rose nice and steady. So, the big question, after all this building and making custom parts and careful firing, did it actually work? Well, the results were, frankly, pretty incredible. The final pieces, and they fired everything from simple earthenware to high-fire porcelain all the way up to 12.80 Celsius. They all showed excellent quality. They were strong, they looked great, and they were honestly just as good as pieces that spend 10 hours in a traditional kiln. The glazes worked beautifully too. Even the lead author of the paper, Bruno Goffet, was surprised. He actually wrote, "It is surprising that despite a lack of precise temperature and power control, the results were consistently excellent. That tells you this method is surprisingly forgiving." And let's not forget about that extra creative control. Using those magnetite-heavy susceptors gave artists the power to create those gorgeous, complex glaze effects that come from a low oxygen firing. That is a huge, huge benefit for a kiln that runs on electricity.
All right, let's wrap this up with a little reality check on safety and what the future might hold for this kind of technology. Because as exciting as this is, it's still an experimental setup, and there are some real dangers involved.
Safety has to be number one. You absolutely need proper ventilation for the fumes. Any air pockets left in the clay can expand and cause the piece to literally explode, so you have to wedge it properly. And of course, the big one, any modified microwave has to be meticulously checked for radiation leaks. The study also found that at super high temps, the iron-rich susceptors could actually react with and melt the insulation if they touched. But you just can't deny the potential here. The time savings are huge. We're talking over 85%. The energy it uses for each piece is right on par with big, efficient industrial kilns, which makes it perfect for the small batches an artist would be making. And the cost to make the most important part, the susceptors, is incredibly low, just 15 to 21 euros for a whole batch. So, this leaves us with a pretty cool final thought. This study points to a way to make making ceramics faster, more flexible, and way more accessible. It really makes you wonder, could a regular old appliance that's already in millions of kitchens become the key to unlocking the future of on-demand artisanal craft?